So for ions, a positive ion is something that has lost electrons. That feels backwards because positive makes you think add, but remember electrons are negative. So if we're losing negative things, that's how we will become more positive. An ion that is negative has gained electrons. And the most important thing to know is this losing and gaining of electrons is always from the outermost shell, or the valence shell. We're generally dealing with the valence electrons. An analogy that might help with that is if you picture me wearing a whole bunch of coats. If you're going to come and either give me another coat or take one of my coats away, it's always going to be the outermost coat. If you give me a new one, I'm going to add it to the outside. If you're trying to take a coat from me, you're going to take the outermost one off. You can't deal with any of the coats on the inside until you've dealt with the outside coat. Looking at iron, I think, is the best way to understand this. Iron, regular old iron, and anytime they're asking you for an electron configuration of an ion, I suggest writing it without losing or gaining electrons and then editing it from there. So iron would be, if I'm telling you, you can use the shortcut, argon 4s2 3d6. Even though I wrote it to the left of this, my fourth shell is outside of my third shell. So if I ask you to write iron, and let's say the question said iron plus 2. Again, I start with normal iron, and then to account for that plus 2, positive means I'm losing, 2 means I'm losing 2 electrons from the outermost shell. My fourth shell is outside of my third, goes 1, 2, 3, 4, etc. I need to lose 2 electrons from that shell, so I'm going to take those 2 electrons away. Now there's nothing in that shell, so really this whole term goes away, and my answer would be argon 3d6. If instead the question asked you for iron plus 3, so now I want to lose 3 electrons, I still would have taken the 2 away from the fourth shell, because that's my outermost shell, but I need to take 1 more. Now the third shell is my outermost shell, and I can reduce that down to 5. A few more examples. Let's say I have oxygen minus 2. Start with regular oxygen, 1s2, 2s2, 2p4. The minus 2 is telling me I need to add 2 electrons to the outermost shell. My second shell is the outermost shell, so you might think, well, do I add it to the S or the P? Remember, the S maxes out at 2 electrons, P maxes out at 6. So I have space here to make this 4, to add 2 more to it, and make it a 6. If you notice, 1s2, 2s2, 2p6, my answer. If you were to look for what else is 1s2, 2s2, 2p6, it's neon. So another appropriate answer, if I said you could use the shortcut, would be neon in brackets. The reason oxygen gains 2 electrons when it becomes an ion is to become what we call isoelectronic, or to have the same number of electrons as a noble gas, because noble gases are stable. If we're losing electrons, so for instance, sodium, your periodic table will tell you is a +1. Starting with regular old sodium, 1s2, 2s2, 2p6, 3s1. The +1 means lose 1 electron. The third shell is my outermost shell. It only has 1 electron in it, so I lose that whole term. Again, what is 1s2, 2s2, 2p6? 1s2, 2s2, 2p6, neon. The reason sodium loses 1 electron is to become isoelectronic with neon. It's not always neon, but it should always be a noble gas. If you're going back to the iron example and saying, well, we didn't just get a noble gas for that one, any of the transition metals will look like it's not just a noble gas, but they will still have that full S and P subshell if you wrote out the whole thing without a short.